Hey, this is Holly connecting with lab2. So over here, I set my memory browser starting with zeros, putting this address so we can kind of see this thing in action. Let's start it. And here at address 200, we have the unsorted array, followed by 210. We in address 210, we have the n amount of elements, and then we have negative 77, negative 65, and ascending all the way until the last element, 87. And so this is at 200. This is unsorted. At 210, sorted. So let's see what happens if we press resume again. And here we go at address 220, n amount of elements and unsorted array 2. And then down here at 230, we have n amount of elements, negative 55, negative 39, and so on until we reach the maximum highest value of 90. So this is working. We can explain the code now. So here we go. So starting out, we're setting all these immediate values. We're populating the array, and as we keep moving forward, we keep incrementing the next slot and moving a new number into it. And same with this second array down here. This is where we're copying our array over with this loop. And so down here, this is where it starts to get interesting. So here, this is where we move R4 into R10, and R4 is the starting address of array 1. And then we increment, wait, wait, where did I go? Where did I go? Sorry. Oh, no, no, I started to, okay, no, no, sorry, I got my place again. All right, so we increment um, R10, right? And then because this is where the actual element, starts. So down, so right here, this is this is where the array starts, and that's our n amount of elements, and R10 is where our actual elements start. So we move R10 into R8, R8 into R9, R6 into R5, and this is storing the starting address of the first array, because we always want to, oh, I'm sorry, into R6 and R5, yeah, into the first array, because we always want to keep that unchanged. Okay, so here we decrement R8, and so that's going to be our loop counter, and this is the bigger loop right here, this loop 1, 1, and so this is going to go through each element until it's sorted. And so this is why, if this is 0, if we go through every element, well, n minus 1 elements, then we're going to return. And so that's, this loop 1, 2 down here, this goes through the ones, and if it's smaller, then it calls a switch label and it switches. But continuing on, so that's why we return here. And then so we move R5 into R6, and so this is moving like the starting value back in here. Increment R6 so that we can get going on the next value. Um, and then we're moving that value into R7, so that we can later use this for comparing them. And so down here we decrement R9, our counter for that, and if it's equal to 0, then we jump back into the bigger loop up there. And so here, this is where we're moving these values into R11 and R12, and so here we're comparing them, and we're saying if R12 is less than R11, then we want to, JL, if it's less than, then we switch them. And so, down here we call this switch subroutine, this label, and if they're, if if R12 is greater than R11, then we just increment R6, increment R7, and then we go back and we don't have to switch them, we don't call anything. And so down here in this switch thing, we're moving, we're like placing the lower value, into R6, and this is how we're gonna swap them. And then this R11 is R7, and we're incrementing these two, and then jumping back into this loop back here, and then this is gonna go eventually back up, and that's it.